So bases, okay, they have hydroxyl ions in common. They have what are called hydroxyl ions in common. So if you have to list some bases, we have potassium hydroxide, we have sodium hydroxide, we have calcium hydroxide. Okay, like this we have different bases that are there. So all the bases have hydroxyl ions in common, and they release these hydroxyl ions in aqueous solution. Those bases which will release hydroxyl ions in aqueous solution, which are soluble in water, are called alkalis. So you have to remember a very important point here, that the bases, the bases can be of two types, that is soluble and insoluble. Soluble in water, bases which are soluble in water, which are insoluble in water. The bases which are soluble in water, they are called alkalis. What they are called? They will be called as alkalis. So the one which are soluble in water, they will release hydroxyl ions. When they are dissolved in water, will conduct electricity and will be responsible for the chemical properties of the bases. That is conversion of the red litmus to blue, the neutralization reaction, conduction of the electricity, all these properties, and reaction with the other substances, whatever I have described in the chemical properties, all those are possible because of the release of the OH minus ions, which are the hydroxyl ions, and the bases which are soluble in water are called alkalis. So those bases which are insoluble in water, these are called alkalis. Which are insoluble in water, these are just called bases. So the bases which are soluble in water are only called as alkalis. So you have to remember that all alkalis are bases, but all bases are not alkalis. They are not alkalis. Why like that? All alkalis are bases, that is, all alkalis which are able to release the hydroxyl ions in water are bases only. But all bases, because they are not soluble in water, though they have hydroxyl ions, they will not release them. So all bases are not alkalis. So that is the simple reason, what you can give for this particular statement, that is, all alkalis are bases, but all bases are not alkalis. So all bases have OH ions in, you understood, what they have in common and why they will become acidic or basic in nature. Just because of the presence of hydrogen ions in acids and hydroxyl ions in bases, the properties are getting conferred on that particular substance. The acidic properties, whatever we have described, or the basic properties, whatever we have described, those are getting conferred on the substance, which is actually making them to be an acid or a base. So now let us talk about what is dilution. What is dilution? Suppose if I have a concentrated fruit pulp with me, if I have to give it to some 5 members of my family, what I'll do, I'll add little water to the concentrated pulp and I will make it into juice which is suitable to be given to all the 5 members in glasses. What I am doing, I am adding water to the pulp, the thick pulp, 1 glass of pulp if I have, I can add water to that and dilute it so that it can make up 5 glasses. So this is what is called dilution. What I have done, I have added water to the concentrated pulp. So like that only, even in chemistry, we have what is called as dilution or diluted acids and bases. So what is dilution? When water is mixed with acids or bases, when water is added to acids or bases, they will be called dilute acids or dilute bases. So when I add water to HCl, it becomes dilute HCl, hydrochloric acid. If I add water to sulfuric acid, it becomes dilute sulfuric acid, and so on. If I add water to sodium hydroxide, it becomes dilute sodium hydroxide. So what is happening in all these cases is we are mixing acid and water. One thing you have to remember when you are mixing water and acid is always and always add acid or base to water. So add. So you have to remember this point very importantly during dilution. Always we need to add acid or base to water, but not vice versa. That is, we should not add water to acid or base. Only acid or base should be added to water. This is a very important question, and what may be the reason for this is the question. So why you cannot add water to acid or base, but always you have to add acid or base to water? Why it is like that is, if you add water, if we add water to acid, what will happen? To an acid or base, what will happen? What will happen? What will happen is, okay, it's an exothermic reaction. Lot of heat will be produced. So if you are adding water to acid in a beaker, what will happen? Because of high heat that is generated, the exothermic reaction that happens, the solution may bump out and it will burn your skin, or sometimes even the tumblers may burst off, the glass tumblers may burst off due to excess of heat. So always care should be taken while adding, okay, acid to water. So always you should add acid to water, that too very slowly, drop by drop, and you should be continuously stirring it. Okay, you should be continuously mixing it and slowly you should be adding it. Otherwise, okay, it may prove hazardous, it may bump out, burn your skin, or even the glass apparatus may broke off because of the highly exothermic reaction that takes place. So do remember that always add acid or base, okay, drop wise to water with constant stirring. Okay, so clear with this concept. So here what is happening, if you are adding the otherwise, it becomes highly exothermic and it is hazardous. It is hazardous. So we have to take care of this particular dilution process. Though we simply say that just adding water to acid will make it diluted, but care should be taken in what way it should be added. Okay, so hope you are clear. When I was talking about acids, I said that acids release hydrogen ions or hydronium ions. Where from this hydronium ion has come? This may be your question. So hydronium ions are nothing but ions which are liberated by the acids will combine with water and they will form hydronium ions. Actually, the hydrogen ions are very much unstable, so they will combine with water and they form hydronium ions. So you can say that actually acids, when they are dissolved in water, they contain hydrogen ions or the hydronium ions. So let us wind off this topic, okay, discussing about some commonly occurring acids and bases. See about some of the commonly occurring acids. So when you talk about your commonly occurring acids, every day we eat lemon. So what this lemon contains? It contains citric acid. Okay. Then every day your mother will be cooking something in a sour way. What she will be adding in that? Tamarind. So tamarind, if you see, okay, and also the grapes what you enjoy during summer, these two they contain tartaric acid, is the acid that is found here. Every day, okay, you eat apple because an apple a day keeps the doctor away. So apple, what it contains, which acid? Apple contains malic acid, is the acid that is present. Okay, so we have all these different acids, and vinegar, that is most commonly used actually nowadays, okay, for your noodles and all. You all might like the noodles. Okay, vinegar basically it contains acetic acid in it. Okay, and most importantly, every day you might have been fed with the most important vegetable, that is tomatoes and also spinach. Okay, spinach is rich in protein and also iron. So spinach and tomatoes, what they contain? They contain oxalic acid. So oxalic acid, there is one problem with this oxalic acid. So tomatoes and spinach, actually they have oxalic acid. Spinach contains more amount of oxalic acid. So what will happen when you make recipes with these vegetables particularly? They may form oxalates in your body and they can combine with calcium, okay, that deposits in your body, forming calcium oxalate crystals. And those individuals who are more prone to kidney stones, in them actually these calcium oxalate crystals can become stones within the kidneys or the gallbladder, and they may create problems. That's why usually the oxalic acid containing foods, okay, if taken in limited amounts, it will be better for those type of people who are more prone to stones, okay, the kidney stones or the gallbladder stones. Okay, then let us see about some of the common bases what we have. So bases regularly, okay, we use the sodium bicarbonate, which is your baking soda. The baking soda in all the baking baking products we use that. And also we have the washing soda, okay, and also we have washing soda is your sodium carbonate, and we have is potassium carbonate is also there. So this potassium carbonate, actually it's used in soaps and also as a cleaning agent it is used. Okay, so this is used in soaps and also as a cleaning agent it is used. Okay, So these are some of the common bases that we commonly find in our day-to-day activities. When we talk about bases, actually, bases, they are soapy to touch. How they will be? They will be soapy to touch, and also they will be bitter in taste, and they are corrosive in nature. What is corrosiveness? When you touch them, you get the blisters on your hand. So you are not at all advised to taste or touch the bases anyhow, okay? But they have those properties. When we use sodium hydroxide pellets in the laboratory, okay, unknowingly if you touch it, it just looks like a camphor pellet, small pellet. So if you touch them directly with the hand, you get blisters on your hand. Therefore, with a spatula, you need to handle such type of corrosive substances. So sodium hydroxide is one of such corrosive base. So bases usually they are corrosive, okay? You are definitely advised not to touch it or taste the bases at any cost. So this is how it goes, and hope you have understood the topic well. Okay, so let me know whether this sort of teaching you enjoy, or the other way, whatever is done in other videos, is good for you.